Hello and welcome to a new video. This is for Algebra 1. This is our Test 3 review, and so this actually goes over two big concepts: solving systems of equations and operations with polynomials. So we start off here with solving each system by graphing, and we start by drawing the y-intercept of 3 and the slope of -1, so down 1, right 1. You don't have to make all these points if you don't want to, but I like to make lots of points on the first line because it makes my line look better, and because then I don't have to go back and make more if I need more points to be able to figure out where they intersect. Because that's what we're trying to do here, by the way, is find where these two lines intersect. So we start at -4 for the other one, up 3, right 4. We can see this point right here, 4, -1 is where they intersect, so that's our answer. Same idea here on 2. Start with -3 on the y-axis. Make sure you put it on the y-axis. We're going to go down 7, right 2. We don't have room to go down 7, right 2, so we're going to go the opposite, which is up 7 and left 2. Put that point right there, draw a line, and then do the other equation. So that's going to be our +3, so +3 on the y-axis, -1/2. Now if we go down 1 and right 2, we've got room, but it doesn't help us meet our line. We have to go backwards, so up 1 and left 2. That gives us this point right here, which is -2, 4. And that is how we solve a system by graphing. Next, solve by substitution. So substitution is where we take what one equation equals and we plug it into the other. So since this one already has y equals, we're going to plug it into the first equation, and we're going to put parentheses around it, and then this is giving us an equation we can solve by distributing the -8. And as soon as I get to 8 times 22, my life is filled with regrets that I made you and I do that. Sorry about that. It's 176. We add our like terms. -2x plus 40x is 38x. We subtract 176 over to the other side. I actually make a mistake here, and then I figure it out, but I decided to leave it in because I subtracted those and said, oh, that's 152, but I forgot to put the negative because 24 minus 176 is a -152. So you're going to see what happens and how I realize my mistake. 152 divided by 38 is 4. And because I put a positive 152, I got a positive 4. Now we go and put that into one of our first two equations. The one that is already solved for y is the easiest. But here's how I noticed I had a mistake. -5 times 4 is -20, and -20 minus 22 is -42. And the worksheet generator I'm using tries to give us the answers between -10 and 10. And even if you're not using a worksheet generated worksheet, not that I know that you would know how that would be, but like in general, like that's a bit weird of an answer. So it would be worth going back and looking. So I went back and looked and noticed, oh yeah, there's a problem. Because the fact that it divided evenly 4 times made me feel like 4 was right. But then I had to say, okay, I've dropped a negative somewhere because it should be negative instead of positive. So I get x equals -4, and then I go back and plug it in. And this time it gives me the correct y value. 20 minus 22 is -2. And I forgot to write this one as a point, but I remember to do that later, like at the end of number 4. So on 4, we don't have one solved for x or y, so we have to do that work ourselves. So the easiest thing to do is to pick this x in the first equation because it doesn't have a number in front. So I get x equals 3y minus 19, and I plug that into the second equation. And we're going to see a really similar sort of distributing, adding like terms, solving happening here. It's a pretty great time, not gonna lie. Except again, 19 times 5 is not terrible. 95, and then we do -15y plus 4y and get -11y. I'm gonna subtract the 95 over and get -88. So divide by negative 11, and we get a positive 8. Now we take that and plug it back in, and the easiest place to do that is right there. So x equals 3 times 8 minus 19. So that would be 24 minus 19. And that's 5. So 5 comma 8. And that's where I realized, hey, I should have put that in parentheses. So that is the appropriate way to put our answers, is in parentheses. Now we're going to solve by elimination. Elimination is my favorite way personally. It's where we try to get the same number in front of either both x or y, but with opposite signs, so that we can add the equations together and have a variable cancel out. And just, I should have on one of these actually went through the effort to show how to check your answer. So since you're getting a point x comma y, if we plug back in x and y, it should work out to give us a true statement if we really got it right. So just throwing that out there. I chose to multiply the second equation by -2 so I could eliminate the y's. I rewrote the first equation underneath the second equation, and then just kind of continued on solving. You have to add the whole two equations together to get a new equation basically that you can solve. And then you take that answer and plug it back into whichever equation you want to, and that gives you the other variable. So this gives me y equals 2. So my answer is -4 comma 2. The next one here on 6 is a little trickier because we're gonna have to multiply both of these by something. And really, like we could do 90 if we wanted to get rid of our x's. I chose to do 12 to try to get 12 in front of y. So times by 2 on the first one, times by 3 on the second one. And really the only problem with elimination is that we can end up with some pretty big numbers, and the bigger our numbers are, the more likely we are to mess up. So just kind of keeping that in mind as something you want to watch out for. So x equals 2, and then we take that and plug it back in to whichever of these equations we want to. So y equals a positive 4. So my answer is 2 comma 4. Now this next section says solve each system, use whichever method you want. And I meant to put on the instructions here, you could get special cases in this section because that's where that's going to happen. So I used elimination, I think, on all 4 of these because elimination is my favorite. And so I looked at 7 and I was like, well, I don't really like any of these methods because 18 and 24 are big numbers. But I ended up deciding to get 12 in front of each of them. I did have to multiply one of them by a negative in order to get them to be opposite signs. But basically having to do 18 times 4, I got 72, and then I'll have to do 24 times -3, which is -72. Oh no, those both cancel out. This is a special case. 64 minus 48 is 16, and 0 does not equal 16, so this is no solution. That means that there isn't an answer to this. There's no 2 numbers that we can put in for x and y that work out to be 16 on the right side. On 8, I was like, you know what, those 2 y's are really similar. I just need to change one of them so that it's a minus instead of a plus. And then that gave me 12x equals 0. Now, don't fall prey to the, oh, it's 0, that means no solution. We got an answer, x equals 0. 0 divided by 12 really is 0. So then we plug it in and we get our y value, and then end up finishing this with 0 comma -7. This next one, let's see. Trying to get a 2 in front of the y's seems like a good idea. So multiply the first equation by 2, which gives me -8x minus 2y equals 18, and oh no, that's 0 equals 0, which is infinitely many solutions. In case it's not clear, the way we decide between no solution and infinitely many solutions is once both variables cancel out, we look to see, do we have a true statement or a false statement? 0 does not equal 16, so that's why we put no solution. And 0 did equal 0, that's why we put infinitely many. This last one's pretty easy. We just need to add the equations together as they are. So we end up with x equals -2, and then we can get y, which is -6. So -2, -6. That's our answer. And now we move on to polynomials. So when we are adding or subtracting polynomials, we just want to remember that we are adding or subtracting like terms, and like terms happen when we have the same variable to a power. So these n to the fourths add together and get 8 n to the fourth. N cubed doesn't have a partner to add with, so it stays the same. 8n squared has the same issue, and then 1 and -1 actually cancel each other out. So this is our answer. I like to do it by starting with the biggest variable and counting down, because I feel like it helps me not overlook things. But you technically don't have to do this unless it said write your answer in standard form. When we simplify the difference here, we have to actually, or the best way, one of the better ways of doing this is to think of these as their opposite signs. So negative, positive, positive. And then do what we just did where we add like terms. So m cubed doesn't have anything else, so it's -6m cubed. Then we're going to go and look for, let's see, m squared. So -8m squared. And then we're going to do the m's together. 5m plus 4m is 9m. And then the -4 and the +8, which is 4. People will like just do -8m squared, but then still do -4m and -8, and that is not correct. We want to change all the things in the second parentheses to a negative. Think of it like you're distributing a -1, if that's helpful. So here we've got b squareds we're putting together. -2b squared plus b squared is -b squared. We've got b's. 5b minus 7b is -2b. To be or not to be? That is a question. Sorry, I was fast there. You might have to go back and pause that. When we're finding the product, we want to think distributive property. And basically, there's 2 of each of these problems, so that you, hopefully, if you need to have help on the first one, you can try the second one on your own. With the distributive property, it's a matter of just like adding the exponents together when you multiply. So 6x squared and 8x squared is 48x to the fourth. I went through this really fast. 6x squared plus and 7x is 42x cubed. 6x squared times 3 is 18x squared. Then on 17 and 18, we can use the distributive property, or we can use the acronym FOIL, which is first, so 4n times 6n, which is 24n squared. Outer, 4n times -8 is -32n. Inner is -2 times 6n, which is -12n, and then -2 times -8 is last, so it's +16. When we FOIL, we typically end up with like terms in the middle that we add together. So this is our answer. If we think of it as a distributed property, it actually looks the exact same. So it's just that we distribute 8b, and then we also distribute -7, and then we add like terms. So hopefully not too bad. Now we can't FOIL on these next two because there's not enough letters, so we're basically just using the distributive property. So times them each by n, which just makes them each have an extra n. Times them all by 1, and I like to write it underneath, like moved over a space, so that my like terms are in a column here, because I think that makes it a little bit easier to add them together. And so this right here would be our answer. Then we do the same thing on this one. Distribute the m. So 5m cubed, and then m squared, and then m, and then I've got to do the 4 as well. So 20m squared plus 4m plus 4, then add my like terms. If you don't do it above and below each other or line it up like this, you just need to make sure you're adding like terms. So squareds add together, m's add together, but like you can't add a squared and a non-squared together. Now factoring for the rest of this, we want to notice that it says factor out the greatest common, or the common factor. So we say, okay, this has 8 and m in common for all 3 of these. That's the biggest thing that we can divide into all of them. So we write that outside our parentheses, and then inside we write all the things after we've divided by 8m. And that's our answer. You can do the same thing on 22. Now, unfortunately, I was accidentally boring and it just divides by 8, but, you know, I guess there's worse things that could have happened to us, maybe. Here we have to split this trinomial into 2 parentheses by saying the n squared splits up into n and n, and the negative 32 splits up by saying what multiplies to get negative 32 and adds to get 4, which is plus 8 and minus 4. Same thing on 24. So m squared splits up into m, and we say what multiplies to get 20, that adds to get 9, which is a plus 4 and a plus 5. 2 more like this because I wanted to make sure we had lots of practice with positives and negatives. So n squared splits up into n and n. What multiplies to get negative 10 and adds to get negative 9, which is negative 10 and positive 1. On the next one, split up the k squared into k and k. And apparently I'm just going to go ahead and write the answer. What multiplies to get negative 6 and adds to get negative 1 is negative 3 and positive 2. Now these next 4 you have to choose a method. Slide and divide and box method are my 2 favorites. And I think I show both of these. Here's the box method. You make a box with 4 boxes inside, like a Punnett square. We do have to do 2 times 9, which is 18. We put in the 2 n squared and the 9. We say what multiplies to get 18, that adds to get negative 19, which is in the middle. And then we are looking at the top, the bottom, the left, and the right, and saying what the greatest common factor is. And that tells us what to put in our 2 parentheses. I went through this really fast, and so if this is giving you trouble, please go back and watch the 7.5 video. On this one, I chose to slide and divide, so maybe that works better for you. On this one, you actually move the 3 over to negative 10 and multiply. You factor like what we were doing a second ago, so what multiplies to get negative 30 and adds to get 7. But then we divide those 2 numbers by 3. If it doesn't divide, we put the 3 in front of x, and if it does divide, then we just go ahead and simplify, and that gives us our 2 parentheses. This next one, I, again, am super annoyed with myself because 9 times 90 is 810, and that's a really big number. And I'm so sorry if you did this all by yourself. I just, so much regret. Like, you'll notice, so I'm actually voicing over, I recorded me writing it while I was watching TV last night, and now I'm voicing it over, and just the reason this is taking me so long is just the oodles and oodles of regret that I have. So I'm taking it easy, going through here, finding the factors of 810. I'm going to end up sliding and dividing on this one because I feel like it takes up less room, sort of, and I end up taking a lot of room here to come up with factors, and it's a bit of an issue here. Like 810 divided by 6 is what? I don't know. Do you know? 135. 7 doesn't go in. 8 doesn't go in. 9 goes in 90 times, which we're getting close to adding to 91. 10 goes in 81, and it's at that moment that I was like, why didn't I think to try that early on? Because that's one of the more obvious factors. And I'm really, really sad that I went through all that effort. So x plus 10 and x plus 81. And that's divide both of those by 9. And if it doesn't divide, you move the 9 in front. If it simplifies, you should still simplify it. But if you end up with it staying as a fraction, you move the bottom number in front. Slide and divide is actually a trick method that, like, you're kind of doing some incorrect math to get your answer. So that's one of the reasons why I like the box method, even though I actually like slide and divide better. Okay, 10 times 5 is 50. What a reasonable number. 25 and 2 add to get 27. So just greatest common factor this, and we get our 2 parentheses, and it's wonderful. Definitely wonderful. Now, on these next two, when you see 4 terms, you should think factor by grouping. Factoring by grouping is where you group the first 2 and the last 2, and you look for greatest common factors. So the first 2 have 8p squared in common and leave you with 2p plus 1. The second 2 have a negative 7 in common, which also leaves you with 2p plus 1. And that's good because that means that 2p plus 1 is what these 2 things have in common, and we can take that out and then write 8p squared minus 7 next to it. That's how we factor by grouping. It's pretty great. It's one of my favorites. On this one, we took out an x squared, and then we take out a 3, and we end up with 6x plus 5 in common. And we can just, have 6x plus 5 times x squared plus 3. Bada bing, bada boom. Now, these last 4 are kind of our special ones that have to do with square roots. So when you have 2 terms, and you can square root both of them, it splits up into 2 parentheses, one with a plus, one with a minus. So for 4n squared minus 25, that'd be 2n and 5. So you do 2n plus 5 and 2n minus 5. When you have 3 terms on these last 2, and the first term and the last term are things you can square root, this is a different pattern where this actually splits into a single parentheses with a squared on the outside. You do the square root of the first and third term, and then you take the sign from the middle term and get a minus 3 squared. So same kind of deal on 36. If this isn't working for you, you can use normal like slide and divide or other factoring to do these last 4. And it does, in fact, give you the correct answer if you can do it correctly. It's just faster if you notice the pattern. Hey, thanks so much for watching. If you've made it this far, you're probably like in my class, and that means you've already subscribed, obviously, and liked the video because you know me personally. But if by any chance you've made it this far and you're not subscribed and you haven't liked the video, then please do those 2 things because it really helps me out as, one of those aspiring YouTubers like I am. Thanks so much, and I'll see you in another video. Bye.